Can you guys hear me? Good morning. First of all, respect. I'm impressed. I was imagining this morning like me and the person opening the door. So you are the guys really understanding what's important in life. So my name is Dan Bogos, so no you in my name. It's easy to remember. And I'll talk today about a combination of two very important mechanisms in our world, billing and LCR. Billing, everybody understands already why important, and LCR because you know, all the companies, all the managers are trying to optimize something, and this is why what LCR stands for. To understand where we are coming from, we were a company doing platform implementations, system integrators out of open source fine-grained components. We got over 9 years of experience with architecting server-side solutions in VoIP environment. We got both wholesale and retail business categories involved, and we are having a slogan to responsibly understanding real-time processing constraints and the seriousness of live system outages. So this is where we came from, and this is where CGRateS got born. What is CGRateS? Is not, I have to give you the bad news, is not a billing system. It's simply a billing engine, and we don't plan of bringing it towards billing system. We are, by purpose, we are keeping it as engine in order to be of course, pluggable into existing billing infrastructure. Most of our customers, they already have invested quite some funding into their existing billing systems, and they also are not big fans of changing overnight towards an unknown open source component. So also, by keeping it with this architecture, we are able to accommodate new components into our customer's network. For example, to add a new VoIP switch, an SMS service, or a data stream. And we are non-intrusive into their setups. So we don't require them to pass their traffic to a switch of our choice, or we don't make them change, most of the time, not even change their configurations. We simply exchange information with their servers. We have a modular architecture. It's easy to enhance it by rewriting specific components. We got quite some components already in our ecosystem and infrastructure, and they all talk to each other, even internally via APIs. As API support, we got JSON, pure JSON over sockets. Then we got also HTTP transport, JSON over HTTP, web sockets, some REST APIs, and we got also Go specific, some Golang specific serialization. We are performance oriented. We got almost everything what we handle is in our cache. We developed our own transactional caching system, and everything what we do is asynchronous from day one. So for that we use this so-called micro threads. They get a performance advantage over the normal system threads. And of course we are feature rich. We got multi-tenancy from, again, day one. We got derived charging, account bundles, LCR, CDR stats, rates history, I don't know, diameter server for the IMS. And we consider and we advocate ourselves to be agile in developing new features. So any crazy idea you might have, just post it on our GitHub, and we are happy to have a look on it. What's very important for us as a project and also for a billing engine as a concept, we are a test-driven development project. So we got today approximately 1,200 tests. I think are even more than that, almost 1,300 tests as part of our build system. So that guarantees us some sort of SLA for our customers. There are of course still cases which we didn't cover, but most of the cases, most of the normal usage cases, we got them covered in our tests. So whenever we do a change to our code base, we run the test, and we also have automatic testing done by, if you know, Travis on GitHub. Every time we do a commit, Travis will notify us if we do false. A bit about our history. These stats are taken by some standalone system, if you know, OpenHub. And yeah, our project is mostly written, you see, 92% in Golang. We are one of the early Golang projects. We started with Go when Go was in weekly releases. So you can imagine what risk we took writing a billing engine in a completely fresh and unknown developing language. In the meantime, Go as well as we grew. I think Go more than us, but that's another story. We got our first commits before 2012, and you can see our code base has grown ever since. I would say constantly. We are not very proud to grow our code base. We are a bit conservative on adding code, but what you see there, I would say it reflects in our adding of the features. So we really grew our features in time. And yeah, you can find these stats also on OpenHub, which used to be Olo. Regarding performance, as I said, we target and we focus a lot on performance tweaking, and for that we provide even our standalone binary, which you can use to simulate or emulate on your own tariff plan and price list. You can see these tests, I have done them on our master like yesterday while I was here. The first test is an internal connection between the tester and the rater, so over within process, and runs about 1 million queries for getting cost, and calculates the time to get the replies back. So you can see we got like about 85,000 requests per second in terms of rate calculations. And this is done on the standard tariff plan which we provide as part within our tutorials. The second test is a test from a different even programming language, from Python. We wrote a load testing over JSON. This is the worst case scenario for us. The JSON serialization, it's the slowest what you can get. And you can see that from outside, from Python, we got about almost 5,000 requests per second. So that should fit almost any network in terms of performance need. That's about, all these things are about rating calculations. There are all sort of other things, of course, to be considered when you talk about performance within your network, like you already know that. As soon as you involve accounting, because the accounting is the only place where we do live database queries, our accounting is not cached. It's the single mechanism which we decided not to cache, and that's with a good reason. Accounting holds the account details, and in case of crashes or other anomalies, we don't want to lose any data from the account. So accounting is the only part which we do live database queries. However, that should be fast enough, because we are using no SQL databases like Redis or MongoDB, and these are the only two supported today for storing accounting data. So again, these two components are also known for being quite fast. This is a schema of our basic subsystems. On the top left there, you can see our oldest subsystem available, the original one, the rating. We call it RALS, since it encapsulates rating mechanism. Then it does accounting, like keeping the account data, and it also does LCR. We could not split this functionality into separate components, although we separate as much as possible, because they are working very tightly coupled. As said, this subsystem calculates cost for events. It maintains your accounts, does this bundle stuff, and it's able also to compute LCR. So this will be the most important subsystem which we have. It's also able to do real-time fraud mitigation. We have, as I will explain you in some next slides, we have real-time fraud mitigation support with automatic actions and such things. The second subsystem, again very important, is our CDR server. It's, as you see, it's a separate component. You can even install it on other servers. It doesn't need to be located with the RALs together. It has a functionality, a centralized CDR server. You can feed CDRs from various sources inside, and you can also do CDR replication with it. We use this mechanism for very fast CDR processing. I would say diskless. It was quite an interesting topic. We support rating diskless CDRs, and everybody or people were asking how can this be possible, because the CDR needs to be stored. Well, we don't store it. We receive it via RPC from your system. We process everything in memory with cache, and then we forward to the server of your choice. So we get this the disk part out of the question, and we also are able to function in this way like a FIFO or message bus. So you just feed CDRs, and on the other side you get them already rated, which is kind of magic, and we don't need to optimize your or work on your own storage schema, or you decide how you store, how you optimize your queries afterwards. So we just do our job and we pass back to you the information. And the third functionality of the CDR server would be forward CDRs to another subsystem of ours, the CGRateS component. Next subsystem which we have is the session manager, and this component has, again, all these blocks which you see. They can function on different servers because they talk to each other via predefined and clear APIs. The session manager will maintain or take decision when to disconnect sessions. It gets information from the switch that, okay, call was started and call was stopped, and everything else it's done within this module. It's able to do balance reservation in real time. This will be done in chunks of time. You can configure the chunks as much as, I think, nanoseconds. You'll get quite some processing, but you can do that. It's also able to do balance refunds. So if we have reserved, if we have booked too much, and the customer, so let's say you have a debit interval of 10 seconds and your customer has only spoken 5 seconds, we are smart enough to give the 5 seconds back. There are, of course, exceptions when he had some minutes billing or other strategies involved, and we are also smart enough to treat all this stuff behind. Another subsystem of ours recently added is the diameter agent. Actually, this is a fully functional diameter server. We call it agent because we forward the information to our subsystems. So we function as an agent, but not a real diameter agent. So you can consider that you can implement stuff like call control via diameter interface for this fancy IMS, which is nowadays more and more in the topic, although it's a very old topic, but it's fresh now because it's getting more and more open source traction. CGRateS, by the way, diameter agent, it's implemented in a pretty modular manner. It's not RFC bounded. You can configure templates of processor templates, so you can decide which information from where you take, and also what are your reaction, what parameters, what attributes you get back in answers and so on. So you can implement your own RFCs. You are not bounded to specific standards. CGRateS, it's the subsystem which does the real-time CGRateS. It's a performance-oriented component again. It involves no disk operations, although it can save itself individual stats. So you can calculate here. We got some concept of stat queues. So for one CDR, you can, or actually one CDR, you can pass it in an unlimited number of stats queues. This gives you the opportunity to do stuff like calculate me ASR for my customer, for my supplier, for the last 1 hour, for the last 1 day, all for one CDR. So this CDR will update all the stats queues in real time. So you can, again, see it as a memory cache, also as a message bus, which does all this in real time for you. And end result, you will be impressed that you can see in milliseconds all these stats working and you can query them live. We have also there real-time fraud mitigation because we can react on stats. So we can react when cost for a customer or supplier is getting high. And we got this built into the CDR stats. Aliasing server, it's able to alias various parts of the information within your request. You can use for that predefined rules. Think about aliasing the IP address towards an account if you want to think about what can alias do for you. For example, in case of billing assurance, passive billing, you don't need to configure anything else. Just alias an IP address to an account within your system. So by doing that, you get a real-time charging without configuring much in your switch. User server, it's some sort of LDAP implementation in our own code. It's able to maintain user profiles, so you can even use it as a standalone server for your website, for example. You create a username and password or user address or anything which you need to store. It simply attribute value pairs there, and is there because sometimes, for example, someone was sending an SMS and we needed to bill it. We only knew CLI. We could not know tenant and all the other information, like whether it's a prepaid or postpaid SMS and so on. So we put this information within the user server. PubSub service, that's something we wanted to have internally with our own type of implementation. It's a publish subscribe service developed again fully by us. We decide to not to use external systems because we are able to control more our code, and also because we were able in this way to write in using our own logic of PubSub. So you can use this service to subscribe, for example, for live balance updates from within your website. If you want to see your customer doing live calls and show him live updates, you simply open, I don't know, a WebSocket or CGRateS and subscribe there for a particular account change. Then you will get the feed live to your web page. History Server is more like a pet project. Was able to, we said it will be cool if we can keep the differences of our tariff plans. So for that we are using Git. You can, with a simple Git diff, see what you have changed in your tariff plans. Of course, sometimes the tariff plan is really huge. It can be up to 500 megs of data. You need some special tools in order to analyze it, but the information is there if you want. Some quick on rating. We have a lot of features inside rating, being one of our oldest module. We got connect fees. You can define rate units, like I want my price, my user pays €2 for 60 seconds, or he pays €2 for I don't know, 1 second. We got rate increments. This is what you tell to the system that the length of your billing interval. So whether it's 60 seconds or whether it's 1 second or 10 seconds or 6 seconds. There are various ways you want to do that. We got rate grouping. This is an important feature because many, I don't know, I know of Mexico, I think, they charge the first minute as a whole and then charge per second. Well, in CGRateS, you can charge it every millisecond of the call differently. We call this rates grouping, so you can define as many groups of rates on a call as you want. So sky is the limit. If you want to leave the first 3 seconds uncharged because you have FAS, you can do that and then start charging the next whole minute, and then again every 10 seconds intervals, and up to you. We got a number rating, again becoming a hot topic, especially in Europe. So you can bill based on your CLI. If the customer is calling from Afghanistan, he should pay more than a customer calling from within Europe. Of course, again, standard price list stuff. So then various rounding methods. You can round up, round middle, round down. We can also very easily add new rounding. We could not think of anything else than these three. Configurable decimals in cost. So for each destination, you can bill or round per a number of different decimals. It's required by many carriers again. You can also define maximum cost per destination. This is something which even here in Netherlands you have it. All this premium number charging, you need to define sometimes the maximum charge for a call. For example, he will not pay more than €5 even if he stays 1 day on the phone. You can also define hit strategy. So as soon as the maximum cost is reached, you can decide whether you want to hang up his call or make it free afterwards. And you can have rate profile scheduling. So you can decide at first of the month, I want to change my tariff plan. CGRateS will be smart enough to split. If you have a call which starts before first of the month and ends after, CGRateS will be smart enough to split in the middle and charge one part with one cost, other part with other cost. We support multiple type of records. We support voice. This is primary for everybody. We support charging data. We support charging SMS, MMS, or we support monetary. This is in case of balances, or generic. So if you want to charge cars, or I know someone was thinking about virtual machine charging, it's also in there. We have multiple category filters and other fancy stuff. On accounting, we do prepaid, which is this real-time balance reservation in chunks. We do postpaid, which is the calculation of your CDR at the end of the call, but involving also accounting. We do pseudo-prepaid, which many of the current so-called prepaid systems were telling that it's a prepaid. So this is prepaid out of CDRs. You get the balance reservation before the call starts, and you get it, you update the balance at the end of the call out of CDR. That's convenient if you don't need to deal with multiple or simultaneous calls out of the same account. You can have unlimited balances per account, and yeah. You can have balance selection, prioritization, so a lot of complex mechanisms are built in. I need to go a bit faster since there is a lot of information. And we support concurrent sessions per account. As said, we also do debit slip when needed. So if, for example, you charge per minute and you have a debit interval of 10 seconds, we are smart enough to know after the 10 seconds that we have already booked the whole minute. So we will be sleeping afterwards. Fraud mitigation, it's all there, part of accounting. You can define a lot of thresholds and reactions, send mail, shut down account to disconnect calls and such things. CDR server. What's important about CDR server is that it can also process offline files. For example, the flat files of DB flat file of OpenSIPS, we support that, and it's pretty interactive. It uses iNotify. As soon as a new CDR is there, it will start processing it. It's asynchronous, so it will process unlimited number of files simultaneously. We also support derived charging, which is a way to queue and bill multiple ways the same CDR. So you can have a chain of distributors for the same call, and if any of the distributors is out of money, the call will be cut, because we emulate the sessions in real time. So for one call, we start internally 10 or 50 calls, depending on how many times you want to bill and in various manners. Okay, regarding LCR now, since I need to get faster. It's a core component logic. It's internally or remotely accessible. It's non-intrusive, and it will inject supplier information via exchange variables. In case of OpenSIPS, we use AVPs to feed back the supplier information into OpenSIPS, so you can afterwards take decision based on what's inside the AVP. You can split the information. You can then use as tags as up to you how you implement it. We just feed you the information that for this call you have this supplier's order. So then you can play with it in the script. It's tightly coupled with a counting subsystem. This gives you a nice feature which is not easy to find. Provides LCR over bundles. So you can get bundles of minutes from your carriers, from your suppliers, and CGRateS is smart enough to consider these bundles during LCR. So if you got 1,000 minutes to be used during weekend, and it's half of the call can be in weekend, CGRateS can also consider this getting cheaper or expensive for you. It will also integrate with traffic patterns. So if you have an LCR, if you know you have an average call duration of 10 minutes, you can calculate the LCR for 10 minutes and not only per minute. You have some advanced profile selection mechanisms, a lot of filters. Again, you can even here do CLI based LCR. So per prefix, a lot of prioritization, activation time, and so on. We extended the functionality through multiple LCR strategies. Talking about strategies, we got the static one, which is the pretty classic one, where you define your suppliers based on static rules. We got lowest cost, where of course you get the supplier with the cheapest cost, and we even got highest cost if anybody wants to use it. Maybe you want to screw your boss or something. Before leaving, we got a special case of LCR, considering since we have CDR stats. This is a special case where you can route based on qualities. So you can decide, I want to get the cheaper supplier, which doesn't have the ASR smaller than 40%. So there is a lot of advantage in this, because you can start offering proper SLA to your customers. We got QoS thresholds that were on thresholds, and then we got pure QoS LCR, which only considers and orders your suppliers based on their quality. It doesn't care about the cost. Of course, here we support LCR profiles, so you can group your suppliers based on a category and then route for the best quality available. And we also have a load distribution where you can tell, I want this much percentage of my traffic to go to a supplier and another to another supplier. Regarding OpenSIPS integration, we have various ways to integrate. We got the REST client for call authorization or LCR querying. You query an API on our side via REST client. We got API accounting for prepaid, pseudo-prepaid, postpaid or rated, and we also got, we support API CDR. Here you cannot do real prepaid because we don't get accounting updates in real time. AV CDR only generates at the end of the call a CDR. All this stuff is diskless, so the communication is pure RPC, all APIs, so it should be pretty fast. We also have MI Datagram. Via MI Datagram, we are able to tear down your call. So when the prepaid balance is exhausted, then we will send a dialog end command to kill your call. We can do also CDR CSV, as I told you, DB flat file, which is still popular in some wholesale scenarios where you get a lot of traffic. And we have an integration tutorial available for the ones who wanted to just check it out. It's all in there. Yeah, made it. So a few minutes for questions if you got any. If I was not talking too fast.
It's an open source project, you said?
Yeah, it's an open source. It's published, as you see there, on GitHub. You got issue tracker, you have public bugs, we don't hide anything. Actually, we don't develop any in-house closed source software. We publish everything because we consider it's way easier to maintain the code afterwards. That's our strength, the community behind it.
So is there a commercial branch to it of any sort?
No. We support SLA on it, so we are able to offer response time on our for our customers, but we also do it on the open source software, so we don't keep private branches. We are afraid to do that because bugs are so easily found by community, and to do closed source and offer SLA, we find it dangerous. Yeah.
This is kind of a fun question about the development process. Since you were using like an emerging language, did you run into some problems with its libraries or as they were being developed or features?
Yeah. Well, one of it was the lack of connectors with others, so we needed to write every single connector. So we wrote for FreeSwitch a connector. We wrote for OpenSIPS API. If you are Golang developers, we have published this MPL library to connect to OpenSIPS via API and MI Datagram. So you can use it in your code. So this was the major issue which we hit. And there were some exotic bugs which we found, but to our luck, they were already solved. By the time when we found them, they were already solved by Google team. So it was just updating. So it really worked well in our case. So that's it. It's a big system. So just take your time and then come on our IRC. We are happy to help you.
Thank you, Daniel.
Thank you.